Okay, so let's go to number 9. Exercise number 9 is once again very similar to the ones before. The only trick here is that you first need to invert the image. Take a look, I will show you. Exercise number 9. Number 9, where is it? Number 9 here. You first need to invert the image. Here, oops, sorry, here it is. Okay, so if you invert the image, notice this is not the original image. Again, you get as the only solid objects these holes here. Everything else are objects which are full of holes. Okay, so the only solid objects being the holes. Now you can use shrink to isolate them, and then you can count them and draw them. Here is the code. I don't want to lose a lot of time in this one. It's very similar to what we did. And this is drawing already the holes. Of course, that to do a plot, you have to recover the coordinates using the find function, okay? So you take a look at the code and tell me if you need some help understanding what's here, or if this is similar to what you did. So I wait a little bit, and if you don't have questions, we proceed to the next. Okay, I guess no questions here also. So let me go to number 10. Exercise number 10 is to use emfill, okay? Emfill is a function that allows you to recover the inside, fill the inside of objects, okay? So, for example, in this case, we have the screws, and I don't know how to call this in English. Alguém sabe dizer portas em inglês?
I can say bitches.
I don't know. So we have these types of objects. Some of those are solid, the others are not. And we want to make all of the objects solid. And the way to do this is using function emfill. Okay, so I'm going to do this one fast and then ask you to do exercise number 11. So exercise number 10, let me go up there. It's like this. So if you run number 10, variable d, I don't have one now, so I can just comment this part. So here you have the original image, okay? And now you are going to do the filling of the image with the option holes, and this will fill the holes of the objects. So now we can show here image B. Oh, sorry, something went wrong. I have to fill not here but in the other image. Let's call here B. Yeah, B. No, A. Yeah, A. And notice you need to invert this image. It's not inverted properly. We need to invert it. So if I say here not, you see here that first this image contains all the objects, some solid, some not. And then when we do the emfill holes, it will fill these holes in there. Okay? So you could have done this with other alternatives, in particular using em reconstruct. Anyone has an idea of how we could do this? Actually, that's how I think emfill does it internally. But now that we know how to use this flood fill mechanism with the em reconstruct function, how could we obtain the image in the bottom starting from the image on the top?
So I think you just read the image, you invert the linearization, and you fill the holes.
Pedro, I couldn't understand very well. What was your first step?
I grab the image, the portas.png.
Okay. You load it.
Yes, just the IAM read.
Yeah,
The,
but so this we've done this already. So this part that I've selected, you see the code? You see my code? This
yes.
part that I've selected, this is already loading and binarizing and so on. What I want an alternative only for this part here. So I want an alternative for the filling part. So what should I put here in my code? I'm not sure if I understood what you said.
We could do like so we have a prior exercise which we select the dots, and we could then expand it to fill the image.
Sorry, I cannot understand. The sound is not very good. Please speak in Portuguese.
Nós fizemos alguns exercícios atrás, em que estávamos a identificar os buracos, e era selecionar isso e expandir os sítios, porque aquilo ficam os pontinhos na imagem. E depois expandíamos e aquilo enchia.
Okay, so now I could understand some 50% of what you said in Portuguese, which is better than in English because the sound is really bad. I don't know if your microphone is okay. Anyone else listen to him very well, or was I the only one who was having trouble?
No, it's kind of difficult to understand.
It's difficult to understand, okay. I think your microphone is not good, Pedro. In any case, I understood what you meant. What he said was, if we could, as we did before in a previous exercise, select a point of the holes, okay, because we could do the shrink, and with the shrink we can select only the isolated points. Those isolated points are the center of these holes. So he says, if we have this center, we can recover the shape of the holes. We could then use this shape to somehow put it on top of this image and close the holes. As if we are using a cork in a bottle. We have the bottle which contains a hole, and we pick up the cork and we put the cork. So we just have to build the corks first, okay? Was that what you were suggesting, Pedro? Is it a good description?
Yes.
Okay, so you were thinking about wine, no? And beer, everything having to do with bottles and corks, I guess. So let's try to do it like this. First, we are going to do the C equals BW morph of A. First, we cannot use this image, we have to use another image. So I have to invert this image. So C equals not A. Oh, not A. Okay. And now we do a BW morph of C and obtain D. And this D is the BW morph using the shrink infinite times. So again, as Pedro was saying, this is similar to what we did before. I did something wrong because I'm doing shrink. It's in the other one. It's in the other one, not in this one. So it was in image A, not in the inverted one. Again. Here we go. So now we have dots for the solid objects and, but this is not correct. It's the other one. Again, this must be not A here. Yes, okay, not A. And now you see that we have here, the dots are corresponding to the objects in the middle. In this image, we are showing the objects as black, okay? Remember, we did the shrink of the inverse of this image. So we pick up these coordinates, this image, and we detect the isolated points. Detection detection. So isolated by E equal, or mask of isolated points equals we have to define a filter, F equals 111 minus 1 8 sorry 1 minus 8 1 111. It's cold here in my room, so my hands are very difficult to type because they are so cold. So F comma D, and this is the places where I have to have the value minus 8. So this is you can review the isolated points detection. Here we have the mask of isolation, isolated points, M ISO. Okay, you see it there. And now, having this, we can pick up the other image. So let's call it C equals not A. Let's take a look at C. You see this C here below? So we can use this image as the boundary image for a reconstruction operation, which starts from the isolated points. Okay, so the marker are the isolated points, and the boundary image is this one that we are seeing, what we call C. So let's do here the reconstruct, which starts with I am reconstruct. The marker is the mask of isolated points. This is C, and the result will be the A, B, C, D, E, F, G, okay, G. Okay. Let's show G. So finally, we have an image with the corks. Okay, so these are the corks that we need to put in the bottom. Now we can just do an OR between both images, A, B, C, D, E, H. So H equals an OR between the original image and my image of the corks. And with this, I have the expected result. Okay. So I think this is what Pedro was suggesting. Pedro, did you do it exactly like this, or do you have some slight differences?
I've done it the other way, the first thing you've done.
The other way? Which other way? Ah, you did it with the unfilled holes. Okay, okay. I get it. So you did it with the other way, but you were suggesting an alternative when I asked. Okay, but you didn't do it. Now I understand. There is yet another alternative which I prefer, which is to flood fill. Let me show you. So if we have this image here, we can actually use as marker all the periphery of the image. So this is where all the points where I'm going to start pouring water, black paint, not black, white, sorry. And when we start putting white paint, I will start flooding all over here. Actually, it must be on the inverse of this image. So let me do the inverse of this image. There, before we proceed. EM show not A. Okay. Okay, now yes. So I'm going to start flooding in the white until I meet the black. So for example, here in this case, I'm going to, the blue part will be all the white except the inside islands of white, okay? So I think this is more straightforward. I use the marker as the canvas of the image, an area around, and then I just do one reconstruction. So this alternative would go in terms of code as follows. So I compute my marker, which is image A times 0, okay, of type logical, so I can do a conversion here to logical. Then I have to put the first row and the final one all the columns as white. So I'm just painting this line and the one on the bottom as white. Now I'm going to paint also the leftmost and rightmost columns. So the first and last column, all the rows will be also white. So here I have the red square. And now I can do a single reconstruction, EM reconstruct of my marker. And my seed will be this image I'm showing. So it's not A. The result will be image H, okay, which I'm showing here. So you see here the result. So this is everything that was filled. If I invert this, now I have exactly what I wanted as well. So three alternatives. Everyone uses the first one, which is very compact, but it's a good thing that you know what it's actually doing on inside internally. And it gives you also a bit more pro-efficiency with the EM reconstructions. Okay, any questions about this exercise?
Setor, eu tenho uma pergunta, mas é depois para a entrega disto no e-learning. Nós temos de usar aquela função edPath, não temos? Porque metendo as fotos na mesma pasta, isto não tem memória, não ultrapassa a memória aceitável.
To submit on e-learning, what I recommend that you should do is this. So, for example, in your folder, here's my folder. For example, I have PDFs, images, a lot of stuff, no? What you can do is, for example, you can compress this, so we'll compress, and this will be a zip, create. Okay, let's wait a little bit. Let's wait a little lot. I don't know why it takes so long. Just a moment, Ricardo. I will ask. Okay, so here is my Aula set zip. This is 140 megabytes. It's enormous, okay? Why? Because it has a lot of images. So before you submit, you first have to go inside the zip file. So don't forget, I clicked in the zip, I went inside, and I deleted what I didn't want. It was big because of the video. So now I delete inside the zip file this folder, these files, okay? And now my zip is much smaller. It's 18 kilobytes, and I can upload freely to e-learning. So this is what I recommend. What you were asking, Luis, is to put, because you don't want to put here big stuff, you are going to put the images in the lib, but this is more complicated. I think this procedure is much simpler, okay?
Okay.
No, it was a question, but I already figured it out.
Okay.
It's okay.
And don't forget to submit, because I'm not the one who has to submit, so I always forget to tell you. But you shouldn't forget. There was one person last week which did everything. I remember he was in the class, but he forgot to submit. And there was no way for him to submit again, okay? So don't forget. Even if you have to put some alarms on your computers or phones, you figure out a way not to forget. But don't trust on me to tell you. Exercise number 11. I want someone to do it. Can someone volunteer to do this exercise? Or at least show the exercise done. No one. It's not difficult. It's just doing more of the same. So we have to come up with a way to isolate the screws from the other ones, which I don't remember the name, porters. and so the solid from the non-solid objects, and put them in different images. So please, some volunteer. I'm really tired of speaking. This is my third class, and so I've spoken for 6 hours in a row. And also, it's better if you do it instead of me, no?
I have some idea, but I don't know exactly what to do.
Okay, but we can tell me your idea. If you want, I can write, and you guide me as I'm writing. Okay.
Okay, we
So
have the
exercise number 11. Let me first set up the stuff, okay? Before you start.
Okay.
Okay, number 11. Okay, so number 11 is like this. So the first part is just, number 11. So I'm just preparing the binarization and so on. So after picking up the original image, now I get to this part, and I'm going to divide this in 3 rows. Okay, now what, Rafael? What should I do now?
Okay, from the last script or the last result of the image we've got in the last exercise, we can shrink everything, then have like, or make a skeleton, and then we have the screws, like it's like a line, and
Exactly.
and the nuts are a point. Then we delete the points.
No,
And
but first, wait a moment, because
okay,
I'm
okay.
trying to write as you are. So first, using shrink, no?
I don't know if it is shrink or scale to make like the
shrink,
skeleton.
because it is the.
Okay.
So so the skeleton uses all conditions. So if you use all conditions, you get something like this. You see. But what you want is for solid objects to get a single point. So you have to do the shrink, which uses only the 2 conditions, okay? So we are going to use shrink instead of skeleton. And now, let me show you here the result of the shrink. You see, this is the result of the shrink. So we have a problem here in this screw because it has some holes inside, okay? So let me first fix this problem by changing the threshold. Now I think this one has some holes inside. Yeah. Okay, not a good idea. Oh, still no. So I'm just going to do something like this. I'm going to do this, and then I'm going to do a PW morph of A, and you remember the close, which removes internal internal points. So okay, so now the objects don't have any kind of point inside because of the close, and the result is what you were anticipating, no, Rafael? So now we have points for solid objects and rings for the others.
Yeah, then we eliminate or erase the points.
Why do you want to erase the points? Tell me.
Because the points are the solid objects without holes, and that's what we want to eliminate from the image.
Or what you want? You want this one? No, we are talking about the one in the middle. So first, let's use the points, and then we can eliminate. But first, let's do this one in the middle. So, so you want to select the solid objects. How to do that?
Filter.
It was like before. Yes, first we need to do the filter to somehow select only the isolated points, no? So let me go pick up the code for the isolated field, the isolated points detection. So first you select only the isolated points, exactly. So here we have the image was B. So here is a B. And we have the mask of the isolated points. I will show it to you. Okay, here are the isolated points. Now what?
Reconstruct, maybe?
Exactly, reconstruct. So C equals EM reconstruct. What is my marker? So where should I start pouring my paint, my white paint?
ISO.
Exactly. So the image which is shown here below, ISO. And what should be the image that conditions my propagation, my flooding?
Initial
Okay.
image.
The initial image is this one, no? Shouldn't be this one because it should be the opposite of this, no?
Yeah.
Look, if we start here in this image, we are going to have a starting point there, okay? And then we are going to start pouring white paint. But because this is black, the paint will not flood anywhere. It will just stop immediately. You see?
Yeah.
But we want the screws first, right?
Yes, we want the screws. Ah, yeah, you're right. You're right, Ricardo. I'm not thinking straight because we are not talking about this. We are talking about this. Okay, so let me explain where I was thinking wrong, because this is where our points are. So if this is where our points are, it actually works as Rafael was saying. Okay. Okay, so you are right, Rafael. It's the original image, A, and let me show you C. It works. So here we have the first image, no? That we want, and we are going to put it in the middle. So in the middle is number 3, number 2, and here 3. Okay, and now how do I do the selection for the non-solid objects? You want to continue, Rafael?
This I have more idea. So we can shrink it again, or starting from B image, yeah, and then erode it one time to eliminate the dots or the solid objects, and then reconstruct it again.
Okay, so you want to compute a D, which is an erosion of B, so BW worth of B eroded once, okay, now we can actually take a look at this D just to make sure. But let's try to figure out what we have here. Wait, this erosion was not good. So let's take a look at B first, the input of the erosion. I think that we have here the white dots. Yeah, we have. The erosion deletes all points. Doesn't work, Rafael. Because also these rings, look at them. When you do an erosion step, they will be deleted. Because all of these white pixels in the ring are neighbor to a black pixel at least.
Yeah.
So they will all be deleted. Anyone? So more ideas. This one doesn't work.
We could use the same filter, right? But instead of being equal to -8, it's equal to anything but -8.
Good idea. So different from -8. This is the mask of the all else. Okay. Didn't work well. Everything different from -8. Should have worked. No. B. I don't know why it didn't work. Should have worked. The places. So I didn't change F, I didn't change B. That's strange, should have worked. So my mask is all the places in which, after the filtering, I get something different from -8. I don't know why it doesn't work. Well, I do it in a different way. Instead of this, because I already have the mask of isolated points, I can just say, I want a new mask, which is given by my image B. Remember, B contains isolated points and everything else. If I do an exclusive OR between the two, I will get only what is not common, okay? The short will give me what is not common, okay? And so I can show you the M is exactly what I want. I don't know why Ricardo's suggestion didn't work. It should have. It should have. No, it shouldn't. No, I don't think your suggestion worked because it is not the places where it's minus, where it's everything else. Yeah, I think you should have to do it like this. Okay. So with this, now I have a mask of the non-solid objects. I can do exactly what Pedro suggested before, which is this. Now it's a D, empty construct. I have a new mask, and it's the original image. Yeah. And now I show the D. Okay, so this is how we could split the objects. More questions? Okay, so we don't have enough time to do exercise number 12. Let me jump into exercise number 12. We don't have enough time to do it, but I want you to think about it and to notice that if you invert the original image, then you have objects, and the only solid objects are the shut face, the mouths which are shut. So the mouth is from the set faces. So you could use this to do again one shrink and be able to isolate only the set faces. I will show you here one possible solution. Okay, so number 12 here. Okay. I think this is being better. Yeah. So you start with this image here, which is the invert, the negation of that. Okay. So in this image, the only solid objects are the mouths of the set faces. So you use a shrink. After you have the shrink, you can isolate that, and so on and so forth. You just continue. Okay. So this one, I leave it to you. You can try to do it at home. Anything else that you need to talk? Okay, so there was still, was it Rafael in the beginning that had a problem in exercise 1? Was it?
Yeah.
We can revisit that exercise. The rest of the people, if you want, you can continue. Otherwise, we will meet next week, okay? So don't forget to prepare the class and see you next week. And stay safe, that's the most important part. So, Rafael, if you can, please share your screen again. And
Okay.
I'm sorry, I'm getting old. What does it mean, nut?
Nuts is the as
Is he
porcas.
calling me crazy?
No,
Nut.
as
Okay,
porcas.
okay, I thought he was calling me crazy. Which was less far from the truth.
Ok, era neste, né?
I think so. So can you print the value of n after the y?
If I can print the value of
N after the while. So just type after N
Okay.
on line 64, for example, you just type N.
n, like
Yeah,
this.
N. Yeah, like that. Right?
N.
Can you write?
Yeah. Six.
Okay. So 6. Yeah. N is 6. It says it printed 6.
Yeah. Printed here.
Yeah. So it's very strange why if you reload it 6 times, it is the same as if you reload it 5 times. It doesn't make sense. Can you put there, just put a bit of, just a 5 there?
Where here?
Yeah.
Yeah, it's different now.
Now it's different, yeah.
Yeah. We saw it that it was different, but if it is n minus 1, I guess it's equal.
Yeah. Yeah. I was telling you to remove n minus 1 and to put a 5 directly. But now it's the same.
Okay,
Yeah,
okay.
it's the same. Yeah, it's the same. Because n is 6. Why the hell? No, this is a mystery. Can I see? Let me take a look at your code. So you do an illusion.
Where here?
And you just count the number of non-zero. This is very strange. Let me do some code. I will share my screen, okay?
Okay.
Okay. So let me just do some code here. This is exercise number 2, no?
Yeah, number 2.
Number 2. I don't remember how I did it, but I will do it again, okay? So we can just do figure, PM show of B, okay? Now for k equals 1 until 100, and now here I'm going to do B equals PM, the morph of B equal k, yeah, but like this. So this is my initial, and this is bk. And now you just do an EM show of dk with the title saying so B null to str of k contains null to str and z of bk. Does it make sense what I'm saying?
Yeah.
And now we just pause. Okay. I think it makes sense. Erode. It's a string. Okay, so if I do a dilation of 1, it contains 22,000. Now I push enter, and the dilation of 2 contains 19,000, 16,000, 13,000, 10,000, 8,000. This makes sense. So I don't know. Yeah, your code has something wrong. I don't know what
Maybe
is
on
wrong
the
in your
6th.
code. We can take a look at it again, but my code was this.
Maybe the initializing of what, n? I start n at 0. Yeah, n2.
It should be the problem, yeah. If you start n at 0. Yeah, but my code is different still. My code is different because this is the. We can take a look at your code again. Can
Okay.
you share?
Yeah.
So you can okay. So I equal m to double. W root of n, and n is 0.
Maybe
so
n
you
plus
erode
1
0
here?
times. No, I don't think so. So you erode 0 times, then you erode 1 time, then 3. Well, I don't see anything wrong with it.
Let me just do
Sometimes,
it. It's equal.
come on. Give some time. Do some. Can you go above?
Yeah.
Yeah, below. Where you are showing the image in this spring tabs and blah blah blah.
Where are you talking
Do a pause after doing the title. Every time you do the title, then you do a pause of
Okay.
0.1 seconds or something, 0.5 or something. Sometimes the title is not positioned in the proper place. So you have to do after that, after the others as well. Okay, can you try again? Just to make sure. No.
Okay, I guess there is not much problem because next time I'll do some code like this. I'll do it different.
No, I got it. I got your, no. So BW is after you erode 6 times, no? Is it?
VW here or not? No.
No, but because BW is after you erode. BW, the big W, that one. That one that you are selecting. That one is computed after you erode 5 times, not 6. Because you start with n0, then n1, then 2, then 3, then 4. Then when it's 6, it's because you eroded when it was 5, and when it's 6, you just you went away. So actually, this VW is after you erode 5 times. And when you put a 5,
where can you see that? Yeah.
So just do it like this. First iteration, n is 0.
Yeah.
Right?
Okay. Yeah.
Second, n is 1. Third, n is 3, and so on and so forth. When you see n equals 6, is because it eroded when n was 5.
5. Okay.
So that's why the 5 is exactly what you were doing there with 5. So if you start with n equals 1, I think it's different here. Oh, come on. I know, no, that's not the problem. The problem is that you are incrementing after you erode. So try to increment before you erode. Yeah, like that.
Okay.
Come on.
The image are the same.
Yeah, let me take a look at the code.
I'm running out of time to submit it because I didn't.
Yeah, go submit and then send me the code and I will take care of it. Yeah, but better that you submit first, okay? So we meet next week, okay? But if you send me an email, I will try to look at it and see what was wrong, okay?
Okay,
So,
thank you.
No problem. Everyone else, do you need some other help or not? I don't think they need. Okay, so see you next week, everybody. Ciao.
See ya. Ciao, ciao.